Guys, this is T. Akash. My admission number is 19BC0326. My name is T. Akash. Today I want to discuss two topics related to wave function, psi and Schrodinger's equation. Hi guys. Now my first topic is about psi, that is wave function. We know what are the waves and we know different type of the waves such as sound waves. In sound waves, the varying quantity is pressure. And then in coming to water waves, the varying quantity in the waves is height. And then in coming to the light, light consists of electromagnetic and electromagnetic waves is also known as light. So the change is electrical field and magnetic field. These two produce light. Now in coming to the matter waves or de Broglie waves, think about what is the varying quantity. Before knowing about the varying quantity in matter waves, let's discuss about standing waves. Standing waves. Standing waves are the waves which are formed between a fixed distance. For example, when we keep two ends fixed and tied a string which is of inelastic material, when we pluck the string, it produces waves. This means that standing waves are produced when two fixed ends with a fixed amplitude without any change. The same situation occurs in the nucleus and the electron. Electron move in a fixed distance from the nucleus. That means the fixed distance, but here the amplitude is changing. The varying quantity is changing. The varying quantity is known as a psi. Psi is a varying quantity in the matter waves. Stop. Now the matter waves changing quantity is psi, and we know from the principles intensity is directly proportional to the amplitude square. As this the follow of the matter waves, intensity is directly proportional to the psi square. And what is the psi square? We know that psi is a complex function. Psi is a complex function. We can represent it as a plus ib. Now psi square defines that psi into psi star. Psi star represents conjugate of psi. That means psi star is equal to A minus IB. A minus IB. That means the product is A square plus B square. Psi square is equal to A square plus B square. And psi is positive and negative with respect to the distance. But in case of psi square, the curve is only above x-axis. That means that it is always positive. It shows the probability of an electron per unit length. We discuss about properties of a psi. What are the properties of psi? Think about. First property is it must be finite quantity, single valued quantity at everywhere, and it must be continuous. At large distances, the psi is 0. And then we know that the derivative with respect to distance and psi is always finite and continuous. Psi is a complex function. It shows the dynamic state of a system. And if we assume minus infinite to infinite region, psi square dr is equal to 1. That means probability of finding the electron from minus infinite to infinite is 1. That means particle exists. Now in case of the Schrodinger's wave equation, first we have to define about psi in the function of x. Now we have two conditions. One is the equation must be linear so that a combination of the solutions can be possible. And second condition is the coefficients are basic parameters such as h, m, q. Now psi is equal to, it is a function of kx minus omega t. Here momentum is equal to k into h dash. That means h dash is equal to h by 2 pi. This means Planck's constant. And energy is equal to h nu into omega. Now psi is equal to f of, we know that psi is equal to function of x. So as I write like in this, e power I into kx minus omega t. From this, a e power I into px minus et by h. Now psi is equal to, the equation is this. Now we differentiate with the help of x. D psi by dx is equal to p I by into psi. From this we can write that p psi multiply with I by I. It gives p psi by minus IH. Now from this equation on varying this, p psi is equal to minus I d omega by dt. Now remember the equation, and incoming derive with time, d psi by dt is equal to minus I e by h into psi. On rearranging this, multiply with I by I, and we get e psi by IH. From this we can write as e psi is equal to IH d psi by dt. Now we know that energy conservation. From this we know that energy is equal to p square by 2m and v of x. Here v is the potential energy of the particle. Now multiply the operator, E psi is equal to p square by 2m into psi plus v of psi. Replace p and omega here. From this we know that E psi is equal to IH d psi by dt is equal to I square means minus 1 and minus, that means minus square. It is the operator d square by dx square by 2m into psi plus v psi. Now take common, take the both. Now here on rearranging this, I psi d psi by dt is equal to v minus h square by 2m d square by dx square into psi. Here psi seems to be like a eigenfunction, and this term is known as a Hamiltonian operator. And here is a term as E. This is eigen energy or eigen value. From this we can say that E psi is equal to H psi. This is the time dependent equation. H is Hamiltonian operator. Now psi is equal to a e power I px minus ed by h. Now we discuss Schrodinger time independent equation. So we can derive only with x is equal to I p psi by h. Okay. From this multiplying I by I is equal to p psi by minus IH. On rearranging this, p psi is equal to minus IH d psi by dx. According to conservation of energy, energy is equal to p square by 2m plus potential energy. Multiply with an operator, p square by 2m into psi plus v psi. On rearranging this, E minus v into psi is equal to p square by 2m into psi. Now here we know that p psi is equal to P psi is equal to minus IH d psi by dt. Substitute the in the equation. E minus V into psi is equal to minus h square by 2m d square by dt, no, dx square. On rearranging this, d square psi by dx square plus 2m by h square into e minus v into psi is equal to 0. This is the time independent equation derived by the Schrodinger. Thank you for listening my video.